Hey everyone, Mr. Fritz here. This is part two of the law of sines and area of triangles notes. So if you didn't check out part one about areas of non-right triangles, make sure you check that out first. This is continuing on from these notes. So we're going to talk about the law of sines, and we're going to kind of derive the law of sines by picking up where we left off with these area equations. We found that the area can be written as any one of these three equations, and I'm going to do a little bit of algebraic manipulation here to these equations. And what I'm going to do is I'm going to divide all of these expressions by the same thing. So that way it's equal. As long as I do the same thing to all of these expressions and they all stay equal. And I'm going to divide all three of them by 1/2 a, b, c. So let's kind of see what happens here. I'm going to take my first expression and I'll divide it by 1/2 a times b times c. And what's going to happen is I have a 1/2 over 1/2. Those 1/2s cancel. I've got a b over b. I've got a c over c. That all cancels. And I'm left with the sine of a over a. So that's kind of cool. What I can also do then is I can divide this other side, or this other expression, by 1/2 a, b, c. And I can also divide this by 1/2 a, b, c. One thing to note is that this actually doesn't equal the area anymore because the area is these equations. If I divide it by something, I'm not really looking at the area anymore, but what I'm doing is I'm creating a new equation that's algebraically equivalent, but not necessarily numerically equivalent. So anyways, let's get back to simplifying these expressions. And now I simplify the 1/2, I simplify the a's, I simplify the c's, and I have the sine of b over b. And finally over here I have 1/2, and a and b all cancel. So this is going to equal the sine of angle c divided by the side c. So what I have is a new equation where I'm relating the sine of the angle a over the side a. And that's really a common ratio between all these other sides and opposite angles. So this is kind of a nice thing. This is the law of sines. You can also see it written as the reciprocals of all of these expressions. I could say it's a over sine a or b over sine b. They're really all the same thing. You can use either equation, doesn't really matter. So why is this helpful for us? Well, it's used to solve problems involving triangles given either two scenarios. Number one, you could have two angles and one side. So if I have a triangle and I have two angles and one side, that could look something like this. I have this angle here, and I have this angle here, and I have one side, let's say this one, really doesn't matter. Or I could have two sides of a triangle and a non-included angle. So I could have, let's say, this side, and a non-included angle means I can't use this one, so I could have this angle. And with just these three pieces of information, I can use the law of sines to figure out all angles and sides of these triangles, or at least almost always. We'll get back to that later. So let's see some examples of this. I want to use the law of sines here to find the value of x. And so we have to take a look at these angles, and really I like to think about it as what is their opposing side, since that's what I'm using to figure out my law of sines, or that's what I'm using for my law of sines. So what I can write is the sine of 37 degrees divided by its opposite side, 23, should equal, let's go back to red here, the sine of 48 degrees over its opposite side, x. And so I'm going to do a little bit of algebraic manipulation here. I want to solve this thing for x. So I might multiply both sides by x. I might multiply this side by x, so I get x sine 37 over 23 equals sine of 48. And then maybe what I could do next is I could multiply both sides by, say I want to get rid of this piece here, so let's multiply it by 23 over sine of 37. I'll take this and multiply it by 23 over the sine of 37, so that this will cancel here, the sine of 37, 23, and I get x equals 23 times the sine of 48 all over the sine of 37. So this is a number, and I'm typing this into my calculator really just as it's written. I'm going to multiply these two things together and divide it by the sine of 37. And once I do all that, it comes out to 32.3 centimeters. So using the law of sines, I was able to figure out what this missing side was. And this is the case where I'm given two angles and a side. So I've got another example for you that's using the law of sines. Give that a shot on your own, and when you're ready, you can resume the video and see how you did. Okay, so here's my example in the U-try problem. Again, I used the law of sines to find my missing side, and I like to think about what the opposite angles are from these triangles, and did a little bit of algebra here to come up with 13.4 centimeters. So there's the U-try. I have actually one more U-try, and this one's a little bit trickier because you actually have to draw the triangle yourself. It's not given to you, but I think you can handle it. So give that one a shot next, and resume the video when you're ready to look at the answer. All right, so here's the final U-try, and same type of situation. You're setting up the triangle ABC. Your triangle might not look the same as this. That's totally fine as long as 49 degrees is opposite 18 and 63 degrees is opposite whatever your side A is. And if we're trying to solve for A, you'll notice that in this example, I did put the A on top. That's just because I got tired of multiplying by the variable and then doing a whole bunch of algebra to get it by itself. So this way I can really only use one step to solve for A. And that's what I did here. So hopefully now you've got a good handle on using the law of sines from this video. And good job.